Okay, so continuing with our fifth lesson for the second quarter on parallelograms, let's try to explore more of the properties of parallelogram using algebra, or by applying algebra concepts to parallelograms and its properties. Okay, so for letter A, we have here this problem for letter A. Given that the perimeter is equal to 40 and BC and AD have different values, what is the value of x and y? So how can we solve for the value of x for this given figure? So since the perimeter for letter A, let's write it here. The perimeter is equal to 40, and we know that the perimeter is just equal to the sum of all of the side measurements of this figure. Therefore, we can say that since 2y minus 2 is equal to 3x, we can say that BC is also equal to 3x, and CD would be equal to 2x. So therefore, the perimeter is just equal to 2 times 3x plus 2 times 2x. And that should give us around 40. 40 is equal to 6x plus 4x. So 40 is equal to 10x. And if we divide both sides by 10, so therefore the value of x is just equal to 4. Okay. Now that we solve for the value of x, we can now solve for the value of y. Since 3x is equal to 2y minus 2, again, the opposite sides of a parallelogram are parallel and are congruent, the same with each other. And since we know that the value of x is equal to 4, so this 3 times 4 is equal to 2y minus 2. 12 is equal to 2y minus 2. So this is 12 plus 2 is equal to 2y. 2y is equal to 14, and therefore y is just equal to 7. Okay, for letter A, so x is equal to 4, y is equal to 7. For letter B, let's try to solve this problem. Okay, so we have here two diagonals in a parallelogram that intersect with each other. You remember the properties of a parallelogram, especially its diagonals. So when the diagonals of a parallelogram intersect, they bisect each other. So that means, let's say for example, we have a point O here. OB is equal to OD. You can also say that OA is equal to OC. Now for this problem, we can say that x is equal to 3y. We can also say for the other relationship that x plus 2y is equal to 15. Now, since we've already stated that x is equal to 3y, we can substitute the value of x for the second equation that we created. So that's 3y plus 2y is equal to 15. So that should give us 5y is equal to 15. And if we divide both sides by 5, we will solve, or we will get the value of y, which is 3. Now, if y is 3, what's going to be the value of x? Since x is equal to 3y, we can substitute the value of y, which is 3. So this is 3 times 3, which is 9. There you go. So for this problem, for letter B, x is equal to 9, and y is equal to 3. Okay, so let's try letter C. Okay, so for letter C, we have here these givens. For this one, they are not side measurements, they are angle measurements. Okay, so what can we say about the angle measurements of a parallelogram? Their opposite angles are congruent to each other. So therefore, what relationship can we get, or what relationship can we derive, or what equation can we create in order to solve or to find the value of x? So for this one, we can say that the measurement of angle A is equal to the measurement of angle C. And we can also state that 3x minus 20 is equal to x plus 40. So that should give us 3x minus x is equal to 40 plus 20. So that should give us positive 2x is equal to 60. And therefore, x must be equal to 30 for this problem. Now, if x is equal to 30, we can substitute that here. So that's 30 plus 40, so this must be 70. And let's just check. So this one is going to be 3 times 3 minus 20, which is also equal to 70. We also know that in a parallelogram, the adjacent angles are supplementary to each other. So if this is 70 degrees, this must be 110 degrees. And this must also be 110 degrees. So therefore, the value of y For this problem, y is equal to 110 degrees. Therefore, for letter C, x is equal to 30 degrees and x is equal to 30 degrees and y is equal to 110 degrees. Okay, and that's how we solve this parallelogram problem for our 5th lesson.